okay, we have this identity to prove. And what we normally try to do is start with the left-hand side and manipulate it till we get the right-hand side, or start with the right-hand side and try to get the left-hand side. And it probably can be done, but this one here, you might find you try a bit with both, and neither of them seems to be getting anywhere nearer the other one. So as a last resort, what you can do is just start with the endpoint and actually assume everything at once. Now, this is not going to be a proof, anything that starts with this, but at least we can try and get a grip on what's going on. So if I think about tan of x over sec x plus 1 equal to this, as soon as I write this down, it looks like, or I am assuming what I wanted to prove. So it's never going to be a proof, because you mustn't assume what you want to prove. You must prove it. But if I did start with that and think about changing it, it's got a fraction in it, so I can multiply both sides maybe by this sec x plus 1. So, okay, so I get tan x on that side, and on this side I'd get cot x, and then I'd get sec x minus 1 times sec x plus 1. Okay, and when I multiply this out, I can do the grid, or I can just use the fact that when you do a plus b times a minus b, and you expand that in a grid or anything else, this is the difference of two squares. It's a squared minus b squared. So these brackets, I don't want a cost, I want a cot. So these brackets after the cot x, oh for goodness sake, cot x times, these brackets will be the first thing squared, sec of squared x minus 1 squared. So sec squared x minus 1. And I know from my squaredy trig that sec squared x equals 1 minus tan. No, it doesn't. It equals 1 plus tan squared x. So sec squared x minus 1 is just going to be tan squared x. So this is cot x. In this case, I am going to use 1 over tan x for cot x times tan squared of x is does equal tan x. Okay, but that isn't a proof. That's good playing around. I mean, tan x matches now what I had on the other side of this. Okay, but this isn't the classic case of we can easily start with the left-hand side and turn it into the right-hand side, or even that we can turn left-hand side and right-hand side particularly easily into a third thing. Okay, but it's given me the idea for a proof. So I think what I need to do is what I've just done. Okay, but I need to find an excuse for it. It turned out that most of the action was going on to do this cot x times this sec x minus 1. So what I'd like to do is start with the right hand side. Okay, which is, to begin with, it's cot, if I can write it properly, cot x brackets sec x minus 1. And what I really know that I want to be looking at to get nice things to happen is I really know that I'd like this to be multiplied by sec x plus 1. But that's not the right hand side anymore. But what I can do is I can divide, I can put a fraction in, and I can put sec x plus 1 in on the bottom, because I want that. If I'm working towards the left hand side, that's in there. And now the top of this fraction is the stuff that I've sorted out in my scribble space. I can put a line through that to not be indicating I want it marked as my proof, but I can refer back to it. So exactly what I did before happens. So this equals cot x, okay, and then I know this expands out to sec squared x minus 1 over sec x plus 1, and I know that that bracket there becomes tan squared x, but I need to show my knowledge of squaredy trig, so I think it's safest to put cot x and then sec squared x, show that becoming tan squared x plus 1, and then I've got the minus 1, and they're going to cancel, over sec x plus 1. Okay, and then, okay, so I want this cot x to now become 1 over tan x times, and this reduces to just tan squared of x all over sec x plus 1. And then obviously these tans are going to cancel, so on the top I'm just going to get tan x, and on the bottom I'm going to get sec x plus 1. and now I have genuinely arrived at the left-hand side equals the left-hand side. Now, I had to kind of do this thinking because normally I would never have thought of just doing that with the right-hand side. I do a step that makes it more complicated, and then everything drops out. So sometimes you have to do a little bit of, in your scribble space, investigation of the identity, but then you think, how do I write that up as a proper proof? I put as required at the end, and I am done.